Yeah, and it's probably travelled maybe 10 or 15 k's to be here at the most. This structure up here with our inlet works, it'll receive about 6 or 7 megalitres a day. So what happens at the inlet works is we're taking out the solids basically, so any like particulate stuff that's come, gone through our pumps, it's up there and it's going into a band screen. That band screen is like, a rotating screen with holes in it through which stuff passes. The holes are about 5 millimeters, so anything bigger than 5 millimeters is going to get picked up by that band screen, and it's going to go up and washed off at the top with some nozzles. Those nozzles are going to push out the bits of stuff that's got stuck on that screen. Screw presses. There's one up here and there's 2 over there. So once that flow passes through the band screen, it's going to go into a grit collection vortex, which is just like a pretty much a propeller around this big like circular tank. And as that what remains of the solids gets forced to the outside, the velocity around the edge of that is obviously going to drop to 0 around the wall, and rather than spinning around, it's going to go settle down the bottom. We've got 2 stages in our odor control unit here. Usually you'd only have one. That first taller green vessel is actually a biofilter, so there are like live organisms in there which are munching up hydrogen sulfide, which is the main cause of odor. After it goes through there, we've got activated carbon in this smaller one just here, and that's like the final stage. It just scrubs it before you suck all of the air and punch it out this vent hole just that we're standing next to right here. So biofilters are great because you don't actually need to do much maintenance on them, but they can't handle a massive influx of odor all at once. Activated carbon can, but once all that activated carbon is soaked up everything, you have to replace it. So we've got 2 stages here. That train along there, closest to our inlet works, is our anaerobic zone. And in the middle here, we have our aerobic zone. Now, just to make it a little bit more simple for us, this is where my knowledge of treatment plants starts to get a little bit hazy. So I'm going to run you through what Tom's given me, and then if you have any specific questions about what's going on, the chemical reactions and such, write them down, think of them, save them from Tom, because he's really going to be able to tell you all of that. So we've got 2 stages here. That train along there, closest to our inlet works, is our anaerobic zone. And in the middle here, we have our aerobic zone. Now, just to make it a little bit more simple for you guys, we're going to start talking about our aerobic zone. The purpose of this is to remove nitrogen. So you do that by adding oxygen. The oxygen is added basically with a big sort of like lawnmower paddle underneath there, and it's turning it up just like a wave in the ocean. When that crashes, you see all of the oxygen, all of that foam. So that's what's happening pretty much underneath us. What's called secondary clarifiers. A lot of older plants have primary clarifiers, which was a great way to get grit and carbon out before it went through anything like a screen. But I'm told that back in the day they cared a lot more about the carbon nutrient in the influent than they did phosphorus and nitrogen. Now that they care about nitrogen, you sort of want a bit of the carbon in there for that bioreactor. So not many of the newer plants will have. What these secondary clarifiers do is that smaller circular area in the middle will be filling up with the water that comes out of this bioreactor here. And we're dropping down to a much slower sort of time for that water to rise through these clarifiers. Tom tells me it's around 1 metre an hour for the water coming in there to rise up, which is slow enough for the activated sludge, which is just heavier than our water, to drop to the bottom, the top. So obviously there's not much water coming out of there at the moment. We're in a pretty quiet part of the day. So when people start getting home tonight, having their showers and all that sort of thing, everything will be moving a little bit faster here. Wastewater happens in like a diurnal, what am I looking for here? Diurnal pattern, so there'll be a peak in the morning and then a peak at night time, and it'll get really quiet overnight. Here we go, this one's doing something for you. No, the water doesn't, but the sludge just stepping into the bottom. You know, anything nasty that would have been in that sewage to begin with. Activated sludge?
Yeah.
Yep. Litres. What do you
percentage, how much water is cleared at the moment?
All the water is free of nutrients at this stage. Yeah, so once it's gone through the middle, the activated sludge has settled out.
Yep.
But all of the water that's gotten here has had those nutrients removed from it. So the purpose of this is so that you don't just waste away all that nice activated sludge, all those good bugs you developed. That's going back in there, but the water is free of those nutrients now.
Okay, so water is coming from the downside?
Yeah, it's coming from the bottom in there, and
rising up and...
Yeah, rising up. The activated sludge is settling out at the bottom.
Because the water is lighter now.
It's actually the principle of clarifier. Okay.
Yeah.
So how does it water coming from from center to the outside?
So you can see there's a few sort of like openings in that middle bit. It'll flow out.
Okay. How about from there?
So that shield just there, the inside one, is like maybe only that deep. So it's going underneath.
Okay.
Yeah, and then
Actually, it's like it's actually not letting the top.
Yeah, that's right. So that's the purpose of that, is just to stop that scum getting out the side. Yeah.
Okay, it's just a little bit down to the.
Yeah.
You can't get out that way. You dose in an aluminium salt. So here where it says alum, that's aluminium sulfate. That'll break apart. You got aluminium cations floating around in the liquid.
Yeah, it breaks down the ions and...
Yep. Your phosphorus will be floating around as negatively charged phosphate. They bump into each other, they make a solid, and then that gets incorporated into your biomass, and eventually it works its way out of the system through your wasting. Converted, apart from your nitrogen gas, which you bubbled out, and your carbon dioxide, which you bubbled out, a lot of your phosphorus, your nitrogen and your carbon has gone into making biomass, the activated sludge that we saw mixed up and dissolved into the reactor. If you let that keep growing, you're going to overload your system. You're going to have too much sludge for it to settle out quickly enough in your clarifiers. And you also got other effects. You got something called your sludge age, sludge retention time. It's a biological process. Things have growth rates and rates that they're happy to survive at. Generally, you want to keep the sludge in the system for about 15 to 20 days to get good nitrogen removal. After that time, you want to suck it out of the system. So what you do is you literally suck out some fraction of your reactor volume. Here, to get a 20-day sludge age, which is about what it would be here, you suck out a 20th of your bioreactor volume. So you got all that brown liquid coming down here. You want to dispose of that, but obviously you're not going to pay for a 20th of that reactor volume to be disposed of as liquid. So you got what's called dewatering, where you try and separate as much of the liquid as you can, because you're at a wastewater treatment plant. You can work with that liquid. You just want to get the solid component out of it. You got a few different ways of doing it. You'll see at a lot of plants they got what we have here, which are filter presses. So it's just filter material clothy type stuff, got little holes in it. And so by both gravity and by smushing that filter material together, you can push the liquid through the cloth whereas the solids get retained on the cloth. So in going around and around and getting compressed, you force out the water drains to underneath, and then that water, called your filtrate, gets pumped back into the reactor, because you can treat that, and then your solids get retained, they get nicely dried. Talking about dryness, what's coming into here is about 0.5% solid, 99.5% water. What you have coming out of this after going round and round will be about 15 to 20% solids, and all the water's been pushed back, and it's called filter cake. It's like this crumbly brown stuff. So after it's been dried out, it goes onto a conveyor belt and into a bin, and that's rich because it's, you know, your microorganisms have sucked up carbon, nitrogen, phosphorus to grow.
Used as manure?
Yeah, it's like a manure product, pretty much. So I think here it gets used for cotton farms. I don't know, but it gets taken from here in trucks. Someone stabilizes it a bit more so it's more friendly to use. And then it's like a fertilizer product for growing cotton out near Toowoomba.
Bioreactor, you pretty much have no biomass, which is mostly your bugs, but you've also got a little bit of you know, any solids and stuff that's in there that didn't get screened out.
Before coming to the clarifier or after clarifier?
I was told this, and I'm going to say before the clarifier, but double check with Tom. The water filters through the belts. Water is recycled, put back in there, but you know, some of the bugs, some of the extra solids that haven't been filtered out get basically just sort of pressed in the belt and churned out at the end. You'll see, we might walk around the other side, there's a big screw which will convey it all up into a big tank, and that is just, we, you know, pay through the bloody nose to get that taken off and dealt with. It can be used as fertilizer or in fertilizer, but we don't sell it. We actually pay to have that taken out somewhere near Toowoomba, I think. So there's a lot of improvement for particularly this dewatering the waste activated sludge. So this one here is our chlorine contact tank. So the idea of this is to remove those last pathogens. This is the only, they all have chlorine contact. Chlorine is one of the ways to remove the nasty diseases and all that. You can also do it with ultraviolet.
Yeah, that's painful, but
yeah, I mean, so
I've done it before.
Yeah,
it's the quartz lenses. And also it depends on the clarity of your water as well. That will also affect it. It's just, yeah.
I mean, yeah, it's all probably much of a muchness, but for whatever reason they've gone with the chlorine here. Guys, this is the opposite of your bioreactor, where you want the water that's coming in being churned around and mixed and diluted. You want the opposite to happen here. So think of like a cubic meter of water. You sort of just think of that as one slug of water, and you want that to spend a certain amount of time, you know, without being sort of mixed and diluted, moving through those different channels as it works its way back and forth. That's because after the chlorine gas is dosed in at the start, you want that to have a certain amount of contact, hence chlorine contact tank. So, you know, there's a flow rate going through here, and there's a certain amount of time which that chlorine actually needs to be contacting. That goes through there. The chlorine sort of treats it all. You don't want that chlorine going out into the environment if you can help it. This is actually the only plant where we do a bit of dechlorination. Most of our other plants just put sort of mildly chlorinated water back in, and it doesn't do too much harm. Obviously, there's not, you know, a whole heap of requirement for it. Overseas, I think there's much more stringent requirements about chlorification, but I think in Queensland it's this place. The chlorination, or at the end of the chlorine contact tank, and that reacts with the chlorine to make what's salt, guys?
NaCl.
Thank you, Emily. Yeah, so it's sodium chloride. That's the one. Thanks, guys. Basically, once this stuff's added, it's reacting with the chlorine, as I'm sure you guys know more about than I do. And yeah, you're just getting slightly salty water going out into the environment, which is no real issue. It ends up in the ocean anywhere. Heck, what's in the